two, by means two. So a binary operation is an operation that is going to work on two elements. Now, first thing first, you need to know if we say something is a binary operation, what do we mean, right? If we say an operation is a binary operation, let's say you have been given that when you have got A star B, then this is going to be equal to A plus B. You see what this is? A star B is equal to A plus B. The meaning is that when you've been given the first number, star the second number, simply get the first number and the second number, you add them. That's the meaning. So if they told you to say find, let's say 4 star 3, this would mean that it is 4 plus 3 and that would be 7. That is the first thing. And again, say if they told you the operation A star B, the binary operation A star B is equal to A to the power B. It means that when you have got a first number, star a second number, the first number, that is the A, right, is going to be the base, and then second number B is going to be the power. Let's say, for example, you have been given 2 star 3. This would mean now where there was A, you are putting 2. Where there was B, you are putting 3. So this is going to be 2 to the power 3, and that is going to give us 8. Say you've been given another one, another binary operation, and you've been told, say, A star B is equal to, say, 2AB plus B squared. That is the binary operation. And then now they ask you to say find A 1 star 2. So 1, okay, let me put 3, 1 star 3. So this would mean this is going to be where there is A, you are going to put 1. Where there is B, you are going to put 3. So that is going to become 2. Where there is A, you put 1. Where there is B, you put 3. And then plus, again, where there is B, put 3. But this one is squared. So this is going to be 6 plus 9, which is a 15. Does this make sense? Right, good. Now say, what do we mean if we say an operation is a binary operation? So if you have got a set G or any set, let's say a set A, and the set A has got elements 0 and 1. If we are saying an operation is a binary operation on this set, it means that after we perform an operation, all the results should be part of this set. Let's say, for example, they asked you to say, is addition plus a binary operation on the set A. What you are going to do is that you are going to get all the elements that are in this set. So you have got the elements 0 and 1. Also here put 0 and 1. Remember, I want to find if the operation plus is a binary operation. So what you do is now you'll be adding everything. 0 plus 0, that is 0. 0 plus 1, that is 1. 0 plus 1, that's 1. And then this one plus this one, that will give us a 2. So you see, this 2 is not part of this set. What that tells you is that the operation plus is not a binary operation in the set A. Why? Because if it were a binary operation, all the results should be part of the set A. Let's work out another one. Let's say I want to find out if multiplication is a binary operation on this set A. So what you simply do is put your terms there. 0 times 0 is 0. 0 times 1 is 0. 0 times 1 is 0. 1 times 1 is 1. So you can see all the values or the results which are put in blue are part of the set A. That tells us that the operation times is a binary operation on a set of on the set A. That is a basic thing we need to comprehend when you're talking about If they ask you, is an operation star a binary operation on this set? That is what you want to find out. You are basically looking at the results. Are all the results part of that set? Let's say, for example, they told you that A star B is equal to, let's say, square root of AB. And then they tell you, is the operation star a binary operation on a set of all real numbers? So for you to determine if it is an operation, they can actually ask you, is the operation star a binary operation on a set of real numbers? And then they'll ask you justify your answer. So what you do is, of course, for me, I know that it is not a binary operation on a set of all real numbers. Why? Because let's say, for example, if A is 1 and then B, let's say, is -1, that to mean we are going to have square root of one A, where there's A will put 1, where there's B will put -1, so that will be 1 times -1, that will give us -1. And we know the square root of a negative number is not a real number, it is actually a complex number. So since we have got a result that is not part of the set of real numbers, that means that our operation star is not a binary operation on this set. Do we get the sense there? Does this make sense? So let's have another thing we need to understand about binary operation is the operations that we can perform. So binary operations have got properties just like sets. The properties of commutativity, some of them are commutative. Other binary operations are associative. You can actually also perform distribution on binary operations, so they are distributive. So when it comes to commutativity, commutativity means that when you have got A star B, it is the same as B star A. That's the meaning. Associativity is you talking about three things. If you have got A star B star C, it should be the same as me first getting A, I'll do the star with B, and then the answer that I get, star C, being equal. You can see this too. That's the meaning of associativity. Now, just to understand more, let's use exam questions to be able to comprehend fully what we are talking about, right? The binary operation star on a set R, that R is a set of real numbers, is defined by A star B is equal to A minus B squared minus 2AB. Show that the binary operation star is commutative. So if you want to show that a binary operation is commutative, what you want to show is that A star B is equal to B star A. All right? Yes, please. Okay, so let's start with A star B. That is going to be A star B. A star B is what we have already been given. That is A minus B squared minus 2AB. Now, what I just want to do is for me to simplify this, all right? Remember, A minus B squared, if you expand it, you are going to get A squared. Just get the A, you square it. Get a power 2, you multiply with the A and the B, which is inside. But remember, the B is negative, so that will give us negative 2AB. And then get the B also square it, so it will become positive B squared. So I've expanded the A minus B squared. Outside, you also have minus 2AB. And this is going to be equal to, I'm going to first get the A squared and I'll get the B squared. Negative 2AB minus, we also have another minus 2AB, that will give us negative 4AB. So this is our A star B. Now we also want to find B star A. So for B star A, the meaning of that is we can see we have simply changed. So since we have changed, at every point where there was A, we'll put B. Where there was B, we'll put A, because we have now changed them. So in the brackets, we are going to have B minus A, remember that is squared, and then minus 2BA. And this is going to give us, let's expand B minus A. Remember, get a B, you square it, get a power 2, multiply by the B and the negative A, that will be negative 2BA. And then get the A, you square it, that will be positive A squared, and then minus 2BA. Again, I'm going to arrange them in order. I'll start with the a squared, and then I write a b squared. Can you see I've got negative 2b and negative 2ba? That will give us negative 4ba. Now, ba is the same as ab. So I can simply say this is the same as 4ab. So can you see that A star B is this, B star A is this, they are the same. So you need to now make a conclusion. Since A star B is equal to B star A, that means that the operation star is a binary operation on a set of real numbers. Does that make sense? Are we moving together? Since A star B is equal to B star A, then star is commutative, because whether you start with the A or the B, it is the same answer that you are finding. Okay. And then the second part of the question is saying find negative 1 star 3 star 2. So this is negative 1 star 3 star 2. So the way you work with binary operations is that first you start with what has been given in the brackets. So start with negative 1 star 3. So what does that mean? It means that where there was, you can see this is negative 1 star 3. So it means where there was A, we are going to put negative 1. Where there was B, we are going to put a 3. So even here, where there is A, we'll put negative 1. Where there is B, we'll put a 3. Where there is A, we'll put negative 1. Where there is B, we'll put a 3. That is all. That's how simple these binary operations are. Okay. So we are going to write, I'm writing this, where there was A, we are putting negative 1, minus where there was B, we put 3. But remember, this is squared. And then minus 2, where there was A, we are putting negative 1. Where there is B, we are putting 3, like that. I'm going to put this in brackets. So this is negative 1 star 3. But remember, we have got a star and a 2, right? This which is outside. I just started with what is inside the brackets. Does this make sense? If you are not okay, ask other than after we have moved from here. That's when you want to ask. Okay? Is this okay? Where? Okay. So what we are saying is, remember, start with what has been given in the brackets here. So we've been given negative 1 star 3. We've already been given A star B. So the meaning of that for the negative 1 star 3 is that what is now going to represent A is negative 1. What is going to represent B is a positive 3. All right. So where at every point where there is a here, we'll put negative 1. At every point where there is a 3, where there is B, we are going to put a 3. Right? Does that make sense? So that's why we've put here, we've put negative 1. Here we've put a 3. But the same way it is, there is a square there, there is a minus, there is a 2 in front. Just put where there is A and where there is B. So after doing this, now let's simplify. Negative 1 minus 3 is a negative 4. Negative 4 squared is a 16. And then negative 2 times negative 1 is a 2. 2 times 3 is a 6. So that is going to give us a 6. And then remember, I've got a star outside, and then I've got 2. So this is going to give us 16 plus 6, that is a 22. And then remember, I've got a star 2. Now again, you can see I've got another operation, binary. Binary means 2. So now we have got 22 star 2. The meaning is that where there is A, we'll now put 22. Where there is B, we'll put 2. So come here, we'll put 22. Here we'll put 2. Here we'll put 22. There we'll put 2. Just the same. So in this one, where there is A, we are putting 22. minus, where there is b, we are putting a 2. Remember that is squared, right? And then minus 2. Again, I'm writing this minus 2. Where there is a, again put 22. Where there is b, put again a 2. All right. So 22 minus 2, that is a 20. But remember, it is raised to the power 2. Minus 2 times 22, that is 44, times 2, that is 88. And then 20 squared is a 400 minus 88. 400 minus 88, that is a 312. So that is the answer there. Does this make sense? If you don't want to ask, it's up to you. You meet with it in the exam or the test. Let the operation star be defined on the set of real numbers as a star b is equal to a squared minus b squared. You can see the operation a squared minus b. We want to compute 2 star 3 star negative 1. Again, remember I said that start with what is in the brackets. So I'll first write 2 star. I'll start with what is in the brackets first. In the brackets, we have got 3 star negative 1. So the meaning of this is that where there is a, we are putting a 3. Where there is b, we are putting a negative 1. So same here, we'll put a 3. Here, we'll put a negative 1. All right. At every point, remember a star b means a squared minus b squared. So where there is a, we are going to put 3. But remember, it's a squared, so square the 3. And then look at this minus b squared. But b is represented by what? By negative 1. So where there is b, we'll put negative 1 squared also. Remember, it's also squared. So this will give us 2 star 3 squared is a 9 minus 1 squared, that is a 1. Negative 1 squared is a 1. This gives us 2 star 8. Okay, 2 star 8. You can see now we have got two terms again. That is, you again do the same thing. It's just now the first term is a 2. So that will be 2 star, the second term is 8. So what is representing A is a 2. What is representing B is 8. So where there is A, we are going to put 2, but remember it's A squared, so that will be 2 squared. Where there is B, we'll put 8, but remember it is B squared, so that will be 8 squared. So this means 2 squared minus 8 squared. 2 squared is a 4, 8 squared is a 64, and that is going to give us a negative 60. Is there anyone that is behind? Okay. Next question is saying, let an operation star on set of real numbers defined be on a set of real numbers be defined as follows. A star b is equal to b squared minus a squared for any a and b being members of real numbers. Is a binary operation is a star a binary operation on a set of real numbers? Justify your answer. So when you have got any number that is raised to a power, okay, like you have got a to the power 2. It doesn't matter what a is, whether it is negative, positive, 0, the answer always, unless if we add a root, all right? If we have got a root, if you have got a negative number inside the root, the answer will not be is not always a real number. And when you have got a fraction, let's say a over b, the answer is not always a real number, because when b is 0, that is undefined. So you just want to take note when you have been given a root or when you've been given a fraction, you might have differences when it comes to the operation. But for this one, as long as it's not a root number over something, more likely going to be a binary operation. Unless if we had, let's say, maybe a to the power b, this might not be a binary operation, especially if a is negative and then b, let's say, is a fraction. like a positive half. Okay, so is a star a binary operation on the set of real numbers? So we have said yes. Justify your answer. You can get any two numbers. So the way you are going to justify your answer is just say yes and then continue. If we get any two numbers, any two real numbers, the result after performing the operation star is always a real number. For example, get any two real numbers. Let's say, for example, 1 star 2. So 1 star 2, what to mean is there will be 1 star 2 there, right? So where there is, now look at this. Where there is A, we are now putting 1. Where there is B, we are now putting 2. Okay, so here where there is B, we'll put 2. So this is going to be 2 squared minus where there is A, we'll put 1 squared. And this will be 4 minus 1, which is 3. And 3 is a real number. So that is how you can justify your answer. Have you gotten how to justify your answer? Okay, good. So the second part of the question is saying, compute 2 star 3 star negative 2. 2 star 3 star negative 2. Remember, as I said earlier, start with what is in the bracket. So this is going to be 2 star. We have got in the brackets a 3 star negative 2. The meaning is that where there is A, we are going to be putting 3. Where there is B, we'll be putting negative 2. So come here. Where there is A, put, where there is B, put a negative 2. So that will be negative 2 squared. Minus where there is A, put 3. That will be 3 squared, like that. So this is going to be 2 star. Negative 2 squared is a 4 minus 9. Okay, this is going to be 2 star. 4 minus 9 is a negative 5. Again, we have got two numbers, 2 star negative 5. So we'll still go back on our operation. Now we have got 2 star negative 5. In this case, where there is A, we'll put 2. Where there is B, we'll put negative 5. So remember, it is B squared minus A squared. So where there is B, we are putting negative 5. And this is supposed to be squared minus where there is A, we are putting 2 that's supposed to be squared. It says 25 minus 4, and that is a 21. Does this make sense? Do we get the sense here? Okay, you don't want to answer me? Define an operation on the set of real numbers. X star y is the x root of y, where x is the index of the radical and y is a radicand. Is a star binary operation on the set of real numbers? Just for your answer. I told you when you have got a root, the answer is not always a binary operation on a set of real numbers. Unless on a set of complex numbers, yes, because every number is a complex number. So we are saying no, this is not going to be a binary operation on all the set of real numbers. Why? You say because n- not all the results after performing the operation star are going to be real numbers. That's when you can give an example. For example, if you have got 2 star negative 1, this is going to be, remember, this is now 2 star negative 1. So where there is x, you put 2. So that will be 2. That's the second root. Where there is y, you're putting negative 1. You can see. So what is the square root of negative 1? The square root of negative 1 is I. I is not a real number. It is a complex number. That is why. So the operation star is not a binary operation on the set of real numbers. Why? Because not all the results after performing the operation star is a real number. For example, if you have got 2 star negative 1, the answer is a complex number. As simple as that. That's how you can justify your answer. The next part of the question is telling us to say evaluate 3 star negative 64. So this is a 3 star negative 64. This is going to be, remember, 3 star negative 64. So where there is x, we are putting 3. So that is going to be third root. Where there is y, we are putting negative 64. So we are finding what is the cube root of negative 64. That is basically a negative 4. Negative 4 times negative 4 times negative 4 is going to give you negative 64. So that is the cube root. It is easy, as you can see. That is why it's even 1 mark. And then number 3, solve the equation 3 star 2x minus 3 is equal to 3. So we have got 3 star 2x minus 3. The meaning is that where there is x, we are now going to put 3. Where there is y, we are putting 2x minus 3. So where there was x, we are putting 3, and that is the third root. Where there was y, we are putting 2x minus 3. And this is supposed to be equal to, remember, this is supposed to be equal to what? So I've done this, 3 star 2x minus 3 is equal to 3. When you are solving radicals equations, because you have got a cube root, just raise everything to the power 3. The cube root and the cube will cancel out. If it was a square root, you square. So those will cancel out, so remain with 2x minus 3 is equal to 3 to the power 3, that is a 27. Take this 3 the other side, that will be 2x is equal to 27 plus 3, which is a 30. Divide both sides by 2, that is going to be a 15. Is that okay? Very good. Next question. The table below shows the operation star on the set G. And the set G has got the elements 1, 5, 7, 11. E.g. 11 star 5 is 7. Like when you get 11 star 5, you can see where these are meeting. It is on 7, right? Doesn't matter whether you start where you start from. Whether you start from this 11 or you can start from the other 11. This one 11 star 5, you can see you are still finding 7. That's where they are meeting. And now the question is the operation star a binary operation? Give reason for your answer. You can see these are the results. All these elements that you can see here are the results after performing the operation star on the set G. You can see you have got 1, 5, 7, 11. All the elements here are part of the set G, which is 1, 5, 7, 11. So you are going to say, yes, the operation star is a binary operation on the set G. Give a reason for your answer, because all the results after performing the operation star on the set G are part of the set G. Does that make sense? Good. Determining the operation star is commutative. So to determine whether the operation star is commutative, you can get any two numbers. Let's say, for example, 5 star 7. So if you say 5 star 7, you see you are getting this answer here, which is 11. So again, now swap them, perform 7 star 5. You see the answer that you are going to get. So if you start with 7, which is here, star 5, which is there, you can see the answer is 11. So we are going to say, since 5 star 7 is equal to 7 star 5, that means that the operation star is commutative on the set G. So yes, the operation star is commutative. Make sure that you give an example, as I've done, and make sure that you write that statement, because it's the most important. Every time they ask you to determine, to show, to prove, you need to write at the end, after you've proved the statement, hence proved or hence shown. That is why the operation star is commutative such language. All right. And then the question is saying again, number 3, evaluate 5 star 1 star 11 and the other one. So let's start with the first. Want to evaluate 5 star 1 star 11. So start with 5 star 1. You can see 5 is here, star 1 is here. You can see the answer is a 5. So 5 star 1 is 5, but remember I've got star 11. So we have now 5 star 11. So 5 is star 11. 11 is there. You can see the answer is this one. So the answer is a 7. Okay. And then the other part of the question is saying 5 is star 7 star 7 star 11. So let's start with 5 is star 7. This is 5 star 7. You can see the answer is this one here. That is 11. And then I'm going to put a star here. Again, we'll also work out this one which is in the bracket, 7 star 11. So 7 star 11 is there. You can see the answer is there. That is a 5. And now want to work out 11 star 5. You can see 11 is here. 5 is here. You can see where their meeting is here. Okay, 7. So that is the answer. Hope that's okay. Is there anyone that is left out? Okay, and our last question here. The binary operation star on the set of real numbers is defined by a star b is equal to a squared minus 2ab. Determine if the operation star is associative. All right, determine if the operation star is associative. I told us that when you're talking about associativity, you're talking about three things. So to show that an operation is associative, what you want to show is that a star b, these two, star c, should be equal to, if you start with a at first and then you star b star c, you can see you can get the a and b in brackets or the b and c in brackets. If they are equal, then the operation star is commutative. So let's start with the first part of the equation. We want to prove that a star b star c. So let's first find a star b star c. Remember, a star b we've already been given here. That is a squared minus 2ab. So where there is a star b, I have put this. But remember this one now, star c. Does that make sense, or I've left out someone? So A star B has already been given here. So I've gotten what A star B is, I've put it there. But remember, it is a star C. So when you're proving associativity, you need to introduce the third term as a principle. So now just put the star C there. Is that okay? Okay. Now, what this means is that now the first term, okay, now the first term is a squared minus 2ab. All right. So this whole term here is now the first term, and this is the second term. So still come here, a star b. So if you have got the first term star the second term, what you do is that you get the first term, which is the a, you square it, and then you get minus 2, you multiply the first term and the second term. That's the meaning of that operation. Okay, please, it's just some English there. So the first term will come back to the operation here. If you have got the first term, you start the second term, you get the first term, you square it. Now in this case, the first term is a squared minus 2ab. So we're going to get a squared minus 2ab. This is our first term. Remember, we're supposed to square the first term. So get this term, you square it. And then what you're supposed to do is now get minus. Okay, so now get a minus. And then you're supposed to write 2 times the first term. Our first term, remember, is a squared minus 2ab. The second term, remember, you have got the second term here, but the second term in this case is not b. The second term means c. So put a second term there. Does this make sense? Have I lost anyone? Pardon? When you have got a first term star the second term, what you simply get is a first term, you square it. Now in this case, our first term is this one. This is the one that is representing a. The second term is this one. This is the one that is representing b, because the first term and the second term are are separated by a star. So where there was A, we are going to be putting A squared minus 2AB because this is the first term. Where there was B, we are going to be putting C because that's the second term. So remember, it's supposed to be A squared minus 2AB. But in this case, our A is being represented by A squared minus 2AB. Okay, so where there is A squared, we'll put A squared minus 2AB. So that's where there is A. Put A squared minus 2AB because that's our first term. But remember, the A is supposed to be squared. That's why I've put this thing and put it in brackets. And then supposed to subtract minus 2. So I've subtracted minus and then a 2 here. And then A. But remember, our A is A squared minus 2AB. That's the one that I've written there. And then our B is being represented by C. That's our second term. That's the one that I've written there. Does that make sense? Very good. So what we do now is us just simplifying this term that we've gotten here. So what are we going to do? A squared minus 2AB. Remember, every time I've been mentioning this, when you're expanding, okay, when you're expanding something that has got two terms, I said first get the first term, you square it. So get the A squared, you square it. That will be A to the power 4. And then get a power 2, you multiply with everything that is inside. So 2 times A squared times negative 2AB, that will be negative 4 A to the power 3B. And then get a negative 2AB, you square it. That is going to be positive 4 A squared B squared. If you want to write A squared minus 2AB, again write again A squared minus 2AB, and then you start crossing and multiplying if that is going to be easier for you. And then this C can multiply with a 2 there. That will be negative 2C. So that negative 2C, I'll now start multiplying with what is inside. So negative 2C times A squared, that will be negative 2 A squared C. Negative 2C times this negative 2AB squared, that will be positive 4 A, B, C. Do we have any like terms here? If they are like terms, you can add them. Yes, please. A power 3. If you get 2, you multiply with A squared, you multiply with negative 2AB. So you can see this A times this A to be 2 times this A squared will give you A to the power 3. Does that make sense? Does it make sense or you're trying to lie? It makes sense? If it doesn't, pardon? Okay, so what you simply do is you get this A squared minus 2AB. Remember, it's squared. Again, write another A squared minus 2AB. You start multiplying this times that, and then this times this, and then this times that. So when you multiply this A squared times 2AB, the A and that A squared will give you A to the power 3. Do you get how it's coming now? Good. Is there any other question? Okay, so we have found A star B star C. The second thing we need to find is now A star. We write A alone and then we do the B star C. Okay, so this is going to give us A. Let's work out first B star C. So here we have got B star C. So we're going to put B star C. The meaning is that where there is A, we'll be substituting B. Where there is B, we'll be substituting C. You get that? Where there is A, we'll be substituting B. Where there is B, we'll be substituting C. So that is going to become B squared minus 2BC. So that is what this is going to give us, because where there is A, we're substituting B, and where there is B, we're putting C. Now that we have found this term, again, this first part, this first part is going to be our first part here. So that is our A. This second part after the star will be the second part here, that is our B. So you can see the A hasn't changed. So where there is A, we are still putting A. So that is going to be A, but remember it's A squared. Minus 2, again where there is A, we are still putting our A. But where there is B, remember B, that's the second part, is being represented by B squared minus 2BC. So if you simplify this is going to give you A squared minus 2, 2A times B squared, that will be 2AB squared, 2A times negative BC, negative 2BC, that will give us positive 4ABC. So now what you want to compare is the thing that is on top, the one in blue, the same as this one down. Is this the same as this? Anyone? Are they the same? Are they the same? So you can clearly see these two are not the same. So you say since A star B star C is not equal to A star B star C, then the operation star is not associative. If they were the same, we would have said that the operation is associative. That is how you show associativity. It might look a bit tricky, but it's not bad. Just do more practice. I'll give you some more questions for you to practice on so that you can just make sure that you are good. Let's answer the last part now. Evaluate 2 star 1 star 3 star negative 1. So first we are going to start with the first part here, which is 2 star 1. So that is 2 star 1. So where there is A, we'll substitute 2. Where there is B, we'll substitute 1 in this thing. So where there is A, we're putting 2. That will be 2 squared minus 2. Where there is A again, we're putting 2. Where there is B, we're putting 1. Okay, that's the first part. This is the 1. And then remember there's a star on the middle, so I'll put a star there. And then we'll go to the second part, that is the 3 star negative 1. Again, we'll go in the same operation. 3 star negative 1, but where there is A, we'll put a 3. Where there is B, we'll put a negative 1. So that will be 3, but remember the A was squared, so even the 3 will be squared. Minus 2. Again, where there is A, we are putting a 3. Where there is B, we are putting a negative 1. Is there anyone left out? Okay, so this is now give us 2 squared is a 4. 2 times negative 2 times 2 times 1, that is also a 4. And then we have got a star. 3 squared is a 9. Negative 2 times 3 times negative 1, that is going to be a positive 6. So this is going to be 0 star 15. Again, we'll go back in our operation, but now this is a 0 star 15. So where there is A, we'll put 0. Where there is B, we'll put 15. So that will be 0 squared minus 2. Where there is A, we'll put 0. Where there is B, we'll put 15. So this is going to be 0 minus 0. And so the answer is a 0.